Hey, Pre-Cal 11. So here we go. We're going to start section 7, which is trigonometry, which is going to be one of the most recurring themes you're going to see in any math you do moving forward. This section is pretty involved. We move away from just your basic right angle triangle, SOHCAHTOA, that you're used to, and we actually put these triangles on your XY axis, and we create sort of rotation diagrams, and it all comes about rotating in space. Now we look at it as rotating in 2D space. You step up your game, you start looking at things rotating in 3D space, which is when you get to some pretty high level math and physics. But right now we're just going to focus on how a line rotates around your XY axis. And this section is going to be a little bit vocab heavy at the beginning, but it's important to get that vocab down. So real quick here, trigonometry, we already know it's about the study of angles. Now, we create an angle by rotating an arm in a counterclockwise direction at its endpoint. So what do I mean by that? If we look at this drawing down below, let's say I have a point on it here and I have a point on it here, right? If that line started off, I'm going to do it in different colors so you can see it. That line started off lying on the x-axis, and then we rotated it around in a counterclockwise direction to this point. So this point rotated from here all the way to here. And we created an angle that we call theta, Greek letter theta. Now, if you move in a counterclockwise direction, you have a positive angle. If you move in a counterclockwise direction, it's a negative angle, and you'll see that more later. Now, the vertex is still 0, 0, and the point on this line has coordinates, what we'll look at in a little bit later. But right now, the important thing to look at is the positive and negative angles. If you go in a clockwise direction, it's a negative angle, as you see here. And if you go in a counterclockwise direction, which is the usual, okay, we create a positive angle. And we always talk about the angle with respect to the x-axis. Now, here's where some of the vocabulary comes into play. Standard position, okay? An angle in standard position, it says right here. An angle in standard position has a vertex at the origin and originates from the positive x-axis. What that means is exactly what I wrote on the question above. It started here, right? And it found its way to here. So this arm, this terminal arm here, originates on the x-axis and starts to rotate around. And this angle is 110 degrees. So you'll see in this tick box here, we rotated in a counterclockwise direction, which gives us a positive direction. We've gone past 90 degrees, because 90 degrees would be at the y-axis, right? And then we've done an extra 20. So we're in what we call quadrant 2. Refresher, if we don't recall, on your grid, that's quadrant 1, quadrant 2, quadrant 3, quadrant 4. Go in a counterclockwise direction, and we end up with 110 degrees. Now, if you rotate in a counterclockwise direction, so if we consider here, right, we take the terminal arm and we rotate it in a counterclockwise direction, clockwise direction. I'm doing the negative one now. You get a negative angle. So you'll see this example down here. I've rotated this direction, so negative 135, right? This would be negative 90 to the y-axis, and then I've gone another 45 degrees. You're going to see some significance to that after. It's all right here, so have a look here to make things a little bit more, sorry, we're jumping from Zoom here, to make things a little bit more follow along one step at a time. Now the last one, you can rotate past 160 degrees. So what's happened here is we've rotated the terminal arm, we'll go back to red, it was lying on the x-axis, right? We rotated it all the way around a full 360 degrees and would have been lying back on the arm again. But then we went an additional 30. So we've gone 390 degrees. And you're going to see that relationship again here in just a minute. So that's our basic. Standard position, terminal arm. All right, so I'm going to say terminal arm. I'm going to say standard position quite a bit. So what does it mean to be coterminal? Well, a coterminal angle, bear with me, trying to zoom this thing out. Okay. A coterminal angle is when we have an angle in standard position, okay, but it has the same terminal side, look at that extra capital O, are called coterminal. So what do I mean by that? In quadrant 1, this first example right here, right? In quadrant 1, there are no, like this angle's this angle. And in this case, it's 40 degrees, right? Now, to get coterminal angles, it's really quite simple. Add or subtract a full rotation of 360 degrees. So if you think about this line hasn't moved. It was at 40 degrees, but I rotated it the reverse direction, a full 360 degrees. So you subtract 360 degrees, and you get negative 320. It's called a coterminal angle. Or in this case, I took my 40 degrees, and I rotated the line a full 360 degrees. So you add 360, and you get 400 degrees. Rotate 2 times 360 in the negative direction, and you get negative 680. So basically, for coterminal angles, you are just adding and subtracting 360 degrees. You can do it as many times as you want. There's an infinite number of coterminal angles. Just keep doing full rotations. Don't freak out about that too much. They're easy to find. Take your really large or really small angle and just keep adding or subtracting 360 until you get to a value in between 360 and 0. Right? So if we look here at example 1, now you'll see I put right on there, there's an infinite number of solutions to this. So I'm going to do a few. Okay? I'm saying if you have theta equals to 120, find 2 positive and 2 negative angles. Now on the actual printed out notes, there are 1, 2, 3, 4, there's 6 answers. I'm just going to show you a couple here. The easiest one is, okay, well, I have 120 degrees. I'm going to add 360. And I get 480 degrees. That's a coterminal angle. So 480 is coterminal to 120 degrees. You could do the opposite, and you could go 120 minus 360, and you get negative 240 degrees, also coterminal. And now you could literally add or subtract a multiple of anything. So on the notes, I've done a multiple of 2 and a multiple of 8. Well, let's just say, okay, well, what about 120 plus 4 times 360? So we're doing 4 full rotations of 360 degrees, and we're just adding that to our original angle. So 360 times 4 is 1,440. And then we're just going to add 120, and we get 1,560 degrees is coterminal to 120. All right, so just keep adding and subtracting positive and negative values. Now, if we want to find the smallest coterminal angle between 0 and 360, it's just division. So if we go to A here, best way to do this is, okay, well, take your big one. Now, you can do what we call blunt force method, right? Blunt force method would be to go, okay, well, 2692, and I'm going to go minus 360, and I get 2332. And then I'm going to go minus 360, da-da-da-da-da-da. That just takes way too long. Don't bother. If it's small enough, sure, but easier way to do that. Take 296, or 2,962, divide it by 360. That'll give you the number of full rotations. So if you do that, you get 7.47 repeating, which means it's 7 full rotations. Okay, so go 360 times 7, and you end up with 2,520. So that's your full rotations, and then you'll have your leftover. So go 2692 minus 2520. 2692 minus 2520, and you are left with the leftover, the 172. So that's the smallest coterminal angle. I'm going to scroll up here. Now, negatives is slightly different. Okay, if we take the negative 1940 and we divide it by 360, we get negative 5.38 repeating. But in this case, if you were to multiply negative 5 by 360, you're going to get negative 1,800. And what you'll notice is if you subtract that, so essentially you're adding 1800, you'll still be in the negatives, because what you're getting is you're getting a value that is 5 full rotations in the negative direction back towards 0, but you need to go one more. So it's actually 6. So when you're negative, whatever your extra bit is, you got to jump up to the next one, 6 full rotations. So, or we can just take our negative 140 and add 360 again until you get to a positive value. So 220 is the smallest positive angle between 0 and 360 for that value. So that's coterminal, finding them. Now the next one, the biggest one, okay, the most important thing we're going to talk about in this whole thing, reference angles. Okay, reference angles, important piece of information here, are acute angles. And remember what acute means? Okay, acute means less than 90 degrees. That's still a highlighter. One sec. Acute means less than 90 degrees. And very important, it's the terminal arm formed with the x-axis. Terminal arm formed with the x-axis. And you'll see here, read that again. Read it again. A reference angle is in between 0 and 90 degrees. Okay? This is going to make a whole hell of a lot of sense when we start using it in section 7.2, 7.3, so on and so forth. Now, in quadrant 1, your angle is an acute angle with the x-axis, so your reference angle is the same. And you'll see here, the reference angle is equal to the angle. Now, when you get to quadrant 2, if your angle theta is here, okay, you have a reference angle here. It's the acute angle created with the x-axis. Now, I want you to disregard sine because you're going to see that in play, but what I want you to do for me is I want you to just do this. Take your calculator. One, make sure it's in degree mode. Okay, it should say DEG on the top of your calculator or just the letter D. If it isn't, you got to push the DRG button until it is. Now, I want you to hit sine 60 and equals. You will get 0.8660. Okay, sine 60 would be this, if it was this angle here, 60. Now, if this was 60, my reference angle, then what's this angle here? Well, it's 180 minus 60, which is 120. Take your calculator again and hit sine 120, and you get 0.866. The reference angle has the same value as the regular angle theta. So the acute reference angle has the same value. What you will notice sometimes, though, is a sign change. And we're going to get into that in 7.2. So here, this is 120, this is 60. If we use the same value, let's just say here, this is my reference angle because it's x-axis and my terminal arm. If this was 60, well, my line has actually traveled 180 degrees plus 60. So you would go 240, which would be your angle theta, minus 180 to get back to just your reference angle. And then for quadrant 4, think about it this way. You've gone all the way around, right? That's your large angle, theta. But you want to know what this little bit is. Well, that's just a full rotation, 360 minus whatever your theta was. So you're looking at these 4 scenarios. You're looking at this scenario. Quadrant 1's easy. Quadrant 2, you're subtracting theta because it's a little bit of room left in quadrant, the upper quadrants. Quadrant 3, you're taking away 180 from the large angle, this whole large angle, because we don't care about this part. We only care about this part here, right? And then for quadrant 4, we're going all the way to 360, but then we're taking away this little, or the big bit, to be left with the little bit. Those are reference angles. So what you need to be able to identify is what quadrant am I in with my starting angle. That's an important part of this. So if we look at example 3, really struggling with my zooming today. Here we go. If we look at example 3, find the reference angle for each of these. And I'm going to draw them. Okay? So 200 degrees. Here is my axis. This is 90 degrees. This is 180 degrees. So 200 degrees is going to be somewhere in here. So this thing is 200 degrees. So what's my reference angle? Well, what angle am I trying to create? This little angle right here, right? Which is going to be theta minus 180 degrees. So 200 minus 180, my reference angle is 20 degrees. B, 300, well, 90, 180, 270. My angle is somewhere in here, right? 300 degrees. This is 300. Well, then how do I get this little bit here? I go 360 minus 300, and I'm left with 60 degrees. That's my reference angle. Reference angle. Now for C, same scenario, except I'm going negative. So it would be 90, 180. You'd be negative 200 this way. Negative 200, right? So well, what does that tell you, right? Negative 200, I don't want negative values, right? I don't necessarily want to know what this is anyways. But if you think about going a counterclockwise direction, you can be like, okay, well, I've gone negative 180, right? But I'm subtracting that. I'm subtracting negative 180 from negative 200, which means I'm adding. So this little bit here is negative 20. But that doesn't help me because I've moved in a counterclockwise direction. I want to know what it is positive. So use your coterminals. I have a negative 200 to start, right? That's what this is. Well, that would be the same as if I add 360 to it, right? Coterminal, I'm going to get a positive value. What do you end up with, right? What's negative 200 plus 360? It's 160 degrees, which means if I went this way, I'd have 160 degrees. So now I have 180 minus 160, which gives me positive 20, which is my reference angle, which is what I wanted to see to begin with. So be comfortable finding reference angles for any given angle because it's going to come in ridiculously handy. And there's going to be information for each quadrant. It's going to vary quadrant to quadrant as to sort of what's happening where. So now let's look at the quadrants. Okay, so now it's determine the smallest positive angle in each quadrant that has a reference angle of 40. Now, if we've been drawing, it really helps. Okay, so 40 degrees. Well, let's just roughly say, okay, that's about 40 degrees. So what's the reference angle in Q1? Well, the reference angle is the angle. So here, the reference angle is also 40 degrees. Now, when we go into Q2, we're saying the reference angle is 40. So if I have a line in Q2, right, here's my terminal arm. This is 40 degrees. Okay, well then what's this, right? Well, it's 180 minus 40 degrees. So in Q2, 140 degrees is the theta angle with a reference angle of 40. Now, if we do Q3, this is 40 degrees, which means this angle, right, is 180 plus 40 degrees. So when you're in Q3, 220 theta degrees, right, has a reference angle of 40. And then when we get into the last one, Q4, we're here. This is 40 degrees, which means this, right, that's my theta, is 360 minus 40, so 320 degrees. Now what you'll notice, if you took your calculator right now and you just hit sine 40, sine 140, sine 220, and sine 320. You're going to get the same numerical amount, but what you'll notice is there's a sign change in two of the quadrants, and we'll talk about that in the next section. So 0.6428. And then if you go sine 140, exactly the same. And then sine 220, exactly the same but negative, and then it'll be the same but negative. That's the whole point of a reference angle. Now if we look at example 5, Determine the reference angle for these. Now again, it helps to visualize, but also you want an acute angle, right? So 612, right? Let's go, okay, well, I want my coterminal, so I'm going to minus 360 from 612. And you get 252, right? So that's between 0 and 360. Well, where's 252 on your grid? 252 is more than 180, so it's in Q3. So this is 252 degrees. So how do I get just this amount? Well, 252 minus 180, and you'll get your reference angle, which is 72 degrees. Negative 420. So let's say I'm going negative direction, right? This would be 360. So I've actually gone negative 1 full rotation and then another 60 degrees, right? So what that means is, well, what's this amount, right? If this is negative 420 degrees, well, I'm going to add 360, which gives me negative 60. But then I'm going to add 360 again, and you get 300. So if you go a clockwise direction, this is 300 degrees. So what's that? Well, 60. If we look at 844, C, right? Okay, well, how many full rotations have I got? I'm not going to draw all those down. 844 minus 360, 484. Not far enough, I got to go down another full rotation. So minus another 360 is 124 degrees. Where is that? That's in this quadrant, right? So that means this is 124 degrees. How do I get this? Well, 180 minus 124. You get your reference angle of 56 degrees. And then the last one is 6,425. So I'm going to do this move here. 6,425 divided by 360. And I get 17.8. So now I'm going to do 360 times 17. And I'm going to subtract that from 6,425. And I get 305, which means I am in this quadrant. So minus 360 minus 305, my reference angle is 55 degrees. So that's reference angles. Practice, practice, practice. Now we're going to talk to you just about the coordinate system and how it lines up with angles on your axis. And this is, you're going to see the unit circle a lot in the next year. So this is sort of where that comes from. So the last thing we got in this section. Okay, guys, so you might be thinking, like, well, what's the whole point? Like, what's the whole point of reference angles and coterminal angles? And it comes down to the trigonometry of right-angle triangles, right? Of being able to use our right-angle triangle trigonometry as this line rotates around, this terminal arm rotates around your grid. And you'll see in this massive circle here, you have mirror images, right? So, like, if you just look at the first one here, here's your terminal arm, and the point is x comma y, because it's an x value and a y value. And you create a right angle triangle with a theta. And then you have r, which is the radius of this circle, right? And Pythagorean theorem is going to be huge here, remember, right? X squared plus y squared in this case equals r squared because it's our radius. You're going to use that a lot because you can find r, which means also r is always positive, right? Because it's a positive radius, it's diagonal. Now, okay, well, as this thing rotates into quadrant 2, we're still creating triangles. And we're creating right angle triangles. In this case, you still have a y, but you have negative x. And that's part of the reason why you see sign differences in the question we did. And I'll show one example of that in just a sec. Now, if we rotate down into here, oh, sorry, side note, go back for a sec. And this, right, this is your reference angle of this same angle. And then when we go down into the third one, we still have a negative x, but we also have a negative y value because we're down here now, right? So you see here, negative x, negative y. And we have a reference angle that is the same as that angle. And then we move into the fourth quadrant, and we have a reference angle that is the same as that angle, but we have a negative y again and a positive x. Now, why does that matter? That is where that whole, if you go back to 2 examples ago, right? I think we used sine was equal to 40 was our example. And we had sine of 40 degrees. But you know what? Just for the sake of numbers, I'm going to use an easier example. I'm going to take sine of 45 degrees. Okay? So let's just say theta here, right? This is 45 degrees. Sine of 45 degrees is 0.7071. So now if that's the reference angle, right? That's the reference angle there. The value of sine of this angle, right, would be 180 minus 45, which is 135. So sine of 135 is also 0.7071. And if we take this as 45 and we add 45 to 180 for our reference angle, we have sine of 225 degrees, which is negative 0.7071. And then if we did the last one, 360 minus 45, right, this last triangle, which is 315, we would also, on your calculator, if you did sine 315, you get negative 0.7. Same number, same ratio all the time, but it changes sign. So why does that sign happen? It happens because of this and because of this. Because if you remember SOHCAHTOA for sine, it's opposite over hypotenuse. And remember, the radius is our hypotenuse and it's always positive. So the bottom is always positive. But if you look here, opposite of these angles is your y value, right? Opposite of the angle, opposite of the angle, opposite of the angle, opposite of the angle. But what changes from Q1 to Q2 with your y? Nothing. But what changes when you get to Q3 and Q4? Y becomes negative. So you have a negative value, which is why your answer is always negative. You're going to see that in explicit detail in the next few sections. It's wonderful stuff when you get into special angles and reference angles, right? You can calculate your special triangles with reference angles, and then you just need to know what quadrant you're in. Are you positive or are you negative? It's great. Like the patterns here are amazing. All right. So now let's just look here at this last example. Well, sorry, 2 examples. So example 6 is find all angles that have a reference angle of 20. Now we've done that quite a few times, right? But this is just an extension. Obviously in Q1, it's just 20. In Q2, it's 180 minus 20, so 160. In Q3, it's 180 plus 20, so 200. And in Q4, it's 360 minus 20, so 340. Every angle will have 4 values, 1 in each quadrant, as reference angles. Now, if we look at the last one, question 7, this is probably the most challenging because it makes you think just a little bit. Okay, so if quadrant 2 and quadrant 4 have the same reference angle and the standard position in quadrant 2 is 165, okay, what does that mean? Look, Q2, Q4. The standard position is 165, which means this angle here is 165 degrees. I'm going to erase that so it looks nice. 165. Well, what does that tell you about the reference angle? Well, it's 180 minus 165, which is 15. So that means this is 15 degrees, right? So then, well, what's the standard position in Q4? Well, what that means then is the reference angle in Q4 has to be 15 degrees. So what's that angle? 360 minus 15, 345. So that is the beginning of trig, reference angles, standard position, coterminal, terminal arm, a lot of vocabulary you're going to have to wrap your head around. Get as comfortable with it as you can, because in 7.2, 7.3, all the way to 7.7, I'm not going to mess around with this stuff. You're going to hear these words and you're going to have to understand what they mean. It's all in this section. It's all in your notes. Don't take it for granted, because if you plan on doing Pre-Calculus 12, you need to understand trig. There's 2 full chapters of trigonometry in Pre-Cal 12. Okay, please. This isn't about can I pass a test. This is about do I understand what I'm doing. And this is very visual at times. Just make sure your learning is top priority, not just getting it done. Okay? Take care, and I'll see you in 7.2.